Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is cycle geometry, we are going to take the third theorem. So let's begin. After completing the very lesson today, my dear student, you'll be able to find the measure of the angle that is formed in a semicircle. This is what I hope you'll be able to do after completing the very lesson today. In your favorite segment of the lesson, that is Maths is Fun. Today, my dear student, I will explain the relationship between letter E and a sequence of odd numbers. I will explain this amazing relationship after completing the very lesson today if you stay with me. My dear student, to begin the lesson, let us learn the third theorem. The theorem says if you have angles which are on the circumference, and those angles are now subtended by a chord, and that very chord is a special chord, it is a diameter, then those angles are always equals to 90 degrees. Let me just make use of this very drawing to explain this very theorem. Looking at the angle x, you can see it's an angle on the circumference. That is the very first criteria, angles which are on the circumference. And that angle x is now subtended by a chord. Look at the chord in dashes. It is this straight line that subtended this very angle x at the circumference. And looking at this chord is a special chord because it passes through the center. Therefore, it is a diameter. So if you have a chord which is a diameter that subtends an angle at the circumference, that angle is always equals to 90 degrees. So in this case, the angle x will now be equals to 90 degrees. Let me just write it. So x equals to 90 degrees. And the reason for this is the short form of this theorem, which is now angle in a semicircle. So if you have angle in a semicircle, remember, is just half of a cycle. That is when a diameter divides your cycle into two segments. Each part is now a semicircle. So angle in a semicircle is always equals to 90 degrees. We now make use of this very theorem as additional tool while solving problems in cycle geometry. So let us just move and take examples. Example number 1, it says from the figure below, find the lettered angle. The letter angle in this figure is this angle letter x. Look at it. And what I can see in this drawing, I have a cycle center O, and I have a diameter because this line passes through the center. And I have a triangle, and this triangle, it was marked that the length of this side and the length of this side are equal. This one mark tells us that the two sides are equal. This is what I can see in this, and I'm asked to find this this angle letter x. Solution to this very problem. In this case, this x I cannot find it, but if I can find this angle, let me just call it theta. Look at the angle. If I can find it, I can now make use of the angle theta to find this x, because basically looking at this triangle is an isosceles triangle. So this angle x is one of the base angles, and we learned that a properties of isosceles triangle base angles are equal. So if I can find the theta, I will now use it to find x. Let me just start with the angle theta. Of course, I am not asked to find it, but you have to. So starting with the theta, the angle theta is an angle subtended by a chord. Look at the chord, and it is subtended the circumference. So this theta is an angle in a semicircle, and the theorem we have just learned says angle in a semicircle equals to 90 degrees. So this angle theta will now be 90 degrees, and the reason is it is angle in a semicircle. So this angle is now known. So I can now find x. To find x is simply the addition of the three angles theta, x, and this very angle, which is also another x, will now give me 180 degrees. So to find the size of one of the base angle, what you simply do, from 180, when you subtract the third angle, in this case is 90, whatever result you have, you divide it by 2. That will give you the size of one of the base angles. So subtracted 90 from 180 will give answer 90, and 90 divided by 2 will give you 45 degrees. So the size of this base angle, which is x, is now 45 degrees. So let us move and take another example. Example number 2, it says in the diagram below, O is the center of the cycle. This is the diagram. This is O. This all serves as the center of this very cycle that you can see here. The question asked is to work out the related angles. The related angles here, it is angle Y and angle X. So solution to this very problem, to find X, let me see how I can make use of this 52 and some other information to find X. I think no way. To find Y also, still no way. So which means I have to find another angle, which I was not asked to find. So let me mark this angle. Look at it. Let me mark this angle as my theta. I can find this angle theta because it's an angle subtended by this diameter, and this angle is now in the semicircle. So this angle theta is an angle in a semicircle. So theta will now be equals to 90 degrees. And the reason is it is angle in a semicircle. So if I have this angle theta, if I consider this triangle, look at this very triangle. I colored it red. This shape of the triangle, look at it, is now red. This angle is now 90 degrees. I have this angle 52 degrees. I can find the angle Y because the three angles added together gives me sum of angle in a triangle, which is 180. So to find the Y, what I'll simply do, I will now subtract theta 52 from 180 to give me the angle Y. So Y will now be equals to 180 minus 90, which is this angle theta, minus 52, which is this very angle. What remains will now be the angle Y. So subtracting the 90 and 52 from 180 correctly gives you result 38 degrees. So reason for making this assumption is this angle in a triangle, which you learn in your SS1. So I now have an angle Y. So what remains is angle X. Looking at this, the two angles Y and X. Is this adducted angle Y, and it's the same adducted angle X. So these two angles will now be equal. I have angle Y as 38 degrees. So X is now equals to Y because it is nothing but angle on same segment. And those angle Y is 38. So X is now also going to be 38 degrees. So this is the size of the angle X. So I have Y as 38 and I have also X as 38 degrees. Let me just move and take one more example. Example number 3 says in the diagram, O is the center of the cycle. The question asked is to find the size of the angle BOC. This is the angle BOC. So I have to draw a line from B to O so that I can see that very angle. Solution to this very problem. So what you do first is to draw a line from B to O so that you can now have the angle BOC. Let me just draw it. Look at the angle B or C. It is this angle that you needed to find. So to find this angle, you now check what are the angles that you needed to find it together with this 56 degrees, so that in the end you now find the marked angle. So let us move. If I can find this angle ABC, of course I can find it because it's an angle in a semicircle. Let me call that angle ABC. Let me find it. That angle ABC is 90 degrees because it's an angle in a semicircle. And if this is 90 degrees, I have this angle 56 degrees. And looking at this triangle ABC, I have two angles. I can always find this third angle. Let me go on and find it. So angle ACB, this third angle, will give me 180 minus 90 minus 56. And the reason is angle in a triangle. Subtracting the two angles 90 and 56 from 180 correctly gives you result 34 degrees. So this angle is now 34 degrees. So let me just move. So I have 34 degrees as this very angle. And looking at this arc, looking at this very arc, the arc AB, subtend angle 34 degrees at the remaining circumference. And it's the same arc AB that subtend this blue angle at the center. And we have just learned in our previous lesson, that is lesson 1, angle at center twice angle at the remaining circumference. So which means this angle AOB would now give answer will now give me result 2 times 34 degrees, and is now going to be 68 degrees. And if I have this angle 68 degrees, I can find the angle BOC by simply adding the two to get 180, because they are simply adjacent angles on a straight line. So this angle BOC that we asked to find would now be equals to 180 minus 68 degrees. And the reason is they are adjacent angle on a straight line. 68 and angle BOC. So subtracting 68 from 180 correctly gives you result 112 degrees. So this is the angle BOC. So with this, I have answered this very question. With these few examples, my dear student, I have come to the end of this very lesson. And let me just move quickly to the last segment of the lesson, that is Maths is Fun, where I promise to explain the amazing relationship between the letter E and a sequence of odd numbers. So I'll start with this very question, my dear student. Do you know that all odd numbers have a letter E in their spelling? That is, if you are to write all odd numbers in words using English language, you are going to have a letter E in the spelling of those odd numbers. Let's just take a very first odd number, 1, 3, 5, 7, and 9. The spelling of number 1, you can see letter E, that is O-N-E. It has letter E in the spelling. Spelling of the number 3 also contains letter E. Look at it, T-H-R-E-E. The spelling of the number 5 also has letter E, F-I-V-E. Spelling of 7, you can see letter E appearing even in 2 places. The spelling of 9 has letter E also. So other odd numbers that are bigger than this, they must end either with 1, 3, 5, 7, and 9. So eventually they must also have letter E in the spelling. This is really amazing. I believe you never noticed this. We see more of these amazing things in mathematics in our subsequent lessons.